All right, good evening everybody and welcome to the final webinar depend on that we're going to cover about the programming MCQs. Thanks everybody for joining. It's just a few days left. In fact, 2 days left for NQT. In fact, I would say there's only one day left. There's only tomorrow and then Saturday and Sunday, depending on which batch you are in, you're going to have NQT, the National Qualified Test for TCS Ninja. So in today's webinar, we are going to cover some programming MCQs. This is one of the sections that is there in the NQT test. So this is a culmination of all of the topics that we've been doing so far. We started the TCS NQT webinars, and then every day we've been doing one or the other coding questions. And so we are going to, yesterday we did a little bit of programming MCQs. Today also we're going to do programming MCQs. So those of you who are attempting and who will probably joined very late, that is who joined very recently, I'll just take 5 minutes, explain the format of NQT to you, explain what we're going to do, and then I'll dive right into the topic that is the topic for today. All right, so the first thing that we're going to do right now is what is the topic, what are all the sections that are available in NQT. And so we have the following sections. Those of you who've been watching regularly will be familiar with these sections. These are pretty like I've been covering them in every webinar, but what we've been covering so far, majority of our time has been spent in doing the coding section. So we have done all the topics of the coding. We have done array topics, we have done string topics, we have done math topics, we have done conditional topics, we have done loops and patterns topics. So all 5 topics have been completed during the webinar, the course of the webinars. You can just go to the YouTube channel of Edyst and keep watching the playlist. So we have a playlist specifically dedicated for the TCS NQT webinars. You can go ahead and watch that, and if you're doing the last minute revision, as most students do, you can go and check the previous webinars. So my advice here is go check the previous webinars, and if you're just starting right now, that is, let's say you just started today, all right, my advice is try to do as many coding questions as possible, because through your some normal logic you'll probably get the English and the quants aptitude, that is through basic maths, basic English. You might get some marks here, but without any practice you are not going to get the 30 marks that are over here. Last year it was 30 marks one question. It's either 0 or 30. You're not going to get anything else apart from that. So if you don't crack this coding on Saturday and Sunday, then you're going to have a tough time. If you have not done any coding, now is the time to go ahead and do the coding questions. Doesn't matter which language you're doing it in, as long as it's an accepted language by TCS, you can go ahead and do it. So please go ahead and do the coding questions that are meant for you in the TCS NQT. And when it comes to the programming MCQs, that is the topic that we're going to cover today. These are 13 marks, but these are difficult 13 marks. As per last year's pattern, they might change. Number one, there could be negative marking, so please read the instructions carefully whether there is negative marking or there is no negative marking. That's the first thing. The second thing is these questions are not as simple as your English and quants. The reason being, you will apply some maths, you will apply some formulas of AP, GP, and you might clear quants, you might clear English, but programming means you really need to know some programming. So if you are just starting today, start with coding, then go to the programming section. All right. So what we're going to do today is cover the programming MCQs questions. Again, this is the second part. This is not the first part. So this is like the second part. The first part we did yesterday, where we covered a bunch of the topics, and I'll just show you which are the topics we did. As per our analysis of previous year's programming MCQs of code of TCS NQT, we have observed that all of the topics are generally from these. So we have these 6 topics over here. Obviously, there can be more. There can be very basic questions on C. There can be more questions, but the questions are all on C programming. So they're all on C programming, right? So even if you did your coding questions on Java or Python, the programming MCQs are still going to be on C programming. That's the first thing. The second thing is this. All of these 3 tutorials we covered yesterday. This is the part 1 webinar. So you can go and check our playlist and you'll find the part 1 webinar which was covered yesterday. If you are not familiar with these concepts of minus, plus, plus, the comma being used as an operator, scoping, associativity, please check the part 1 webinar. Once you check the part 1 webinar, you will be able to understand these concepts. they are not related to 456. So even if you have not seen yesterday's webinar, it's completely fine. You can still watch today's webinar and understand the topics of pointers, which is really the most difficult. This most people find this difficult. So I'll share a few things on how you can think of the pointers. Don't be too scared of them. Don't think too much about them. It is a difficult topic, but with sufficient conceptual understanding, you can also clear this topic. Then we will cover order notation and searching sorting. These two are actually very easy concepts. The problem is most students don't learn this properly in first year, and that's why they get a problem. So if you watch the 20 minutes or so of what we will do in order notation and searching sorting, that should be enough for you to crack any of the questions that will come accordingly on this. So yes, before I start into 456, please make sure you subscribe to this channel, and make sure you share this video with all your friends so that they can also join in and learn these important concepts of the programming MCQs that we're going to have, that surely will come in the Saturday Sunday NQT. And make sure that you subscribe to this channel, because you'll keep getting updates not only on NQT but all of the campus rounds that are going to come up later on. So there will be campus rounds of Wipro, of AMCAT, and we're going to do all of these in the upcoming session. So if you click subscribe, you're going to get the notification for all of these. All right. So okay, so let's start with the concept of pointers. And I'm sure that some of you might have already, okay, one second, yeah. So some of you might have already know a little bit of pointers. To you, those who already know pointers, you will feel that this is a very basic explanation. But there are many students who since their first year have not really done any programming, and you've just come right now. And even if you go to the coding questions, pointers are generally not used. Like in all of the coding questions that we have done in all our webinars, we have never really used pointers. So how do you actually do pointers questions? We'll cover some of the basics of pointers, what actually pointers do. And those of you who already know a little bit of C programming, this might seem basic to you, but just stay with us and you'll get some information about the next topics also. So what a pointer does is, first of all, this is the way you define a pointer. So that is int star ptr. Star ptr is nothing but it's telling that the ptr variable is a pointer, and you print the pointer using a mod p. So mod d is for integer, but you'll print it using mod p. Now what this star ptr does, what a pointer does, is a pointer actually holds the address of a variable, right? So it actually holds the address of a variable. And the address will be in the same format that the computer will store it. So for example, here int a is equal to 5, right? So let's say there's a box which has 5, this is a, and it has some address, right? So let me just call this addr1. Although in the memory it's going to be like some hex value, it's going to be like 0x something something something, but let's just leave that for now. You have this address 1 where you are storing 5, right? Now when you do int star ptr is equal to and a, two things to understand here. What is a star and what is an and? And means the address of a. So address of a is nothing but addr1, right? That's the address of a, and this value is stored in ptr. Okay, so and ptr itself has some address, because obviously it itself is holding the address of another variable. So it, let's say, is addr2. That's the second address. The first address is this, which has 5, and this is a, and then ptr has this address, because ptr is equal to and a, and a means nothing but it is the address of a. So we are going to store the address of a into ptr, and that's what's happening here, addr1. So when we do int star ptr or int star ptr is equal to and a, what we have is nothing but the address of a is being stored into ptr, and star ptr tells us that ptr is a pointer. When we print this, what's going to be the output here? It's going to be addr1. Now again, I'm saying addr1, but what I really mean to say is the hex value that's going to be stored. Just to make it simple for you, I called it addr1, but it's going to be some big hex value. That's how C is going to store its own address, right? So that's what it's going to be. Now when it comes to this one, printf mod d star ptr, whenever you have a pointer, two rules to note over here. Okay, if you do and of something, and of a variable, let's say variable, it will give you the address of the variable. All right, and whenever you do star of a pointer, so for example, if you did int star ptr, you're going to get the value of the address that is stored in PTR. What does this mean? It's going to go, star PTR is going to go into PTR, it's going to find address, then it's going to go to that address, that's ADDR1 here, and then it's going to print this value. So here you would get the answer as 5. So if you print this, first you are going to get ADDR1, and then the second output is going to be 5. So just to repeat what I just said, whenever you have a pointer, there are 2-3 operators that you need to know. This is how you define a pointer. Okay, int star PTR is equal to and a. All right, that is how we define a pointer. Now when we are going to print a pointer, it's going to print the address that is stored inside it. When we are going to print the integer, we are going to print star PTR. Right, now what does star PTR mean? Star PTR means print the value of the address that is stored in PTR. In PTR we have stored the address ADDR1. So print the value that is stored in ADDR1. So what is the value stored in ADDR1? ADDR1 over here has 5. That is the value stored in it. So then we have 5 over here, which we print 5, right? So that is the concept of pointers. Now there's one more concept in pointers that you need to know, which is that what happens in an array. Okay, so let's look at this again. We had over here int a equal to 5, so we just covered this part of it. So we covered the first part of it on how pointers are actually declared. I hope you understood this much. Again, just to recap, because I know it's a confusing topic, just to recap a little bit, what we have is int star PTR equal to and a means address of a is stored into PTR. So we have a over here, right? We have some there is some address of a. This is a 5 value, some address, right? That value is stored into PTR. So this is PTR ADDR1, and it itself has some address ADDR2, let's say. Again, all of these are going to be hex values. When we do star PTR, it uncovers the value that is there on this address. So it goes here, finds ADDR1, goes to ADDR1 and prints the value that is there, which is 5. That's what it's going to do. Now, the other interesting thing about pointers is whenever you have an array, and I'm going to cover 1D array here, 2D array is a little complex, but once you're done with this session, please go and read about 2D arrays. And on the Edyst platform, you will find some sample MCQs. So you can read about how 2D arrays work with pointers, but I'm skipping that part. So over here we have 1D array, int ARR3 is equal to 7, 8, 9, right? So that is 7, 8 and 9 are here. What ARR is ARR is the array that's there. It's also the pointer to the first value over here. So you can also say that ARR is nothing but AND of ARR0. Okay, this is also, what does this mean? The address of the first value is stored as ARR. So ARR is also the array, yes, but it is also a pointer to the first location of the array. And if you remember from your arrays classes, arrays is nothing but a contiguous data structure, which is nothing but if you have, let's say, 0, 1, 2, these are the indexes, and you have over here 7, 8, 9. In the memory, the array is going to be stored as a continuous block. That is, wherever the memory is, 8 is going to be next to 7, 9 is going to be next to 8. It's not like 7 is stored somewhere, 8 is stored somewhere else, 9 is stored somewhere else. It's not like that. It's like they're all stored together in the same array element, so in the same block. In fact, whatever is the address over here, let's say the address, just saying it's some 0x something 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 4, the next address is going to be 0x something 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 8, because the size of an integer is 4. So it's going to differ from one block to another block just by 4. Similarly, here to here, it's again going to differ by 4. So it's going to be a continuous block. Now, whenever you have int ARR like this ARR pointer is actually the pointer over here. It points to this particular block and the address of this block over here. So it points to 7, which is nothing but if I declare another pointer that is like this, int star ARR PTR equal to ARR. Notice I didn't put an AND over here because I didn't need to put an AND, because ARR in itself is a pointer. So ARR itself is a pointer. When I do int star ARR PTR is equal to ARR, what I'm saying is this ARR pointer is also pointing to ARR, right? So I hope you understood that. In an array, the first element's address is what is stored in the arrays. So the array, basically the array name is also a pointer to the first element's address, and since it's a pointer, when you define a new pointer like ARR PTR, we can actually point it to ARR. Okay, so I hope you understood that part. Now if I go a little bit further in this, what will be the values of these things: star ARR, star ARR PTR, and ARR plus plus? Well, star ARR and star ARR PTR are going to have the same value because ARR and ARR PTR are same. And what are the values of those? Star and star of this is nothing but 7, because they are both pointing to 7, and then you get this. ARR plus plus, or rather even ARR PTR plus plus, what it does is, since there's a pointer here, it's going to increment the pointer to this part. So when you do a plus plus, it's actually going to increment from one position to another position. That's what the plus plus in this case in terms of the array pointer is going to do, because it is pointing to one location in the array element, sorry, in the memory. The moment you do a plus plus, and in integers the plus plus will do a plus 1, here it will go ahead in the memory. So it's going to actually go ahead in the memory. So it's going to move ahead in the memory. So this is another way of traversing arrays. Go check it out. How do you traverse arrays using pointers? It's another cool way of traversing arrays, and it can be used to confuse you in MCQs. So with that done, let's look at a few questions from this topic. All right, so I'm going to use like about 2-3 example questions, and let's see what we can get out of it. Okay, all right, so let's look at this question over here. This was again asked in previous years at TCS NQT. So we have int a equal to 10 and star p. Just throwback to yesterday's class, here star is being used as a separator and not as an operator. So it could come as an MCQ to you. Anyway, so we have a, sorry, not star, comma is being used as a separator and not as an operator over here. So it's being used as a separator. What we have is the good practice when you're doing array questions or pointer questions is that you actually draw it out. So if you draw out this thing over here, what you get is you get a value 10, A has it, and you have a star P, so you have some pointer, right? We don't know what's inside it. There's nothing inside it right now, and there is something, there is some address here, let's say ADDR1, right? This is P, it has its own address ADDR2, but it doesn't store any address inside. We have another int star VP, so we have VP, let's say this is ADDR3, that's its address, and it has again nothing inside. So now we have P equal to AND A. So P stores the value of the address of A, which is nothing but ADDR1. VP equals to P. So again, here also we have ADDR1. When we print mod D star P, remember what does a star P do to a pointer? It goes to that pointer, which it did here. It goes to address 1, and it uncovers the value that is at address 1. So address 1 is this. It uncovered this value and we got this 10, right? Similarly, over here, it will go and try to print star VP. What does it do? Star VP is ADDR1. What is the value at ADDR1? It's again 10. So we have 10 here. So the answer to this question will be 10, 10, right? It's not going to be error. It's not going to be something else. The answer is going to be 10, 10. Okay, so that's the answer to this question. Let's go to the next question. I hope everyone understood this. If you have doubts, just ask on the chat section, and the team will be there to answer your questions. And if you still have not got your questions answered, just wait till the end of the session. At the end of every session, we do a Q&A session. So we will be answering all of your doubts at the end of the session. Okay, all right. So let's go to the next question of pointers. This question involves usage of arrays and also the plus plus. Great. Okay, so again, like I said, at any time, whenever you get an array on a pointers question, just draw it out. So we have A is equal to 1, 5. So let's say this is 1, this is 5, this is ADDR1, ADDR2, and again this is just a short form for address. So it's address 1, address 2. Whatever I'm going to do, printf mod D star A. So what is the value of A right now? A is nothing but A itself will have, actually A is this value. So this is the value of A. This address 1 is the value of A. The moment we do star A, it's going to print 1, comma. So because the comma is there, then it does star A plus plus. So what is star over here? Star A is nothing but 1. When it will do 1 plus plus, it will become 2. So this thing changes to 2. So this becomes 2 over here. Then printf mod D star A is 2. So then we print 2. So the answer for this is 1, 2. Okay, that's how it does. Again, the easy way to solve any pointers question is just jot down all of this in a what you could say, just draw the diagram for it. So over here we drew the diagram. In every diagram, make sure that you have the value, the address. Okay, these two things you must have, and also what this actually is it P, is it A, whatever. So once you draw this out, solving this question becomes easy. So solving these type of questions become much easier. Let's look at a final one, and this is actually a bigger question. So let's look at a final question before we move on to another topic. So okay, this is a slightly bigger question and it uses the concept of size of. I hope everybody can see this on the screen. Let me just check if everyone can see on the screen or not this particular thing. All right, so I believe everybody can. I'll just get a feedback if it's too small. I'll increase the size. Anyways, so yeah, okay, it's very much visible. So what we have over here is int array I equal to 1, 2, 3. So you have an array I which is 1, 2, 3, which is nothing but you can see that you have this array is it's of integers. So that's how this array is. So what actually happening over here is you have one second. All right, so you have over here array I equals to 1 to 3 and array C is equal to 1 to 3. So let's just read it fully and let's see if we can understand each part or not. So int array I is equal to 1 to 3, int star ptr I. Okay, so there's a pointer. Then you have in character, arrays of character is equal to 1 to 3, character star ptrs is equal to array of character. So now the first thing many of you will get stumped is, hey, this itself will give an error because this is a character array but these are all integers. So how do we take care of that? Well, in this case I believe that it will not be an error, but these 1, 2, 3's ASCII values will be taken. So it's not going to be an error as such. The ASCII values are going to be taken into the character array, so it's not going to cause us any problems. And you can, so if in such times whenever you have a doubt, just pause and actually go and try to do it on your own compiler. That's the best way to get away with all of your doubts, because at the day of NQT you won't be able to do it. So best is to do it now and check whether this actually will give the ASCII values or not. So it looks like it's going to give the ASCII values. Then we are doing some printing statements and we're going to use the size of over here. Just if you remember all of our classes and your first year classes, just a refresher, the size of an integer in C is 4. So that's for integer it's 4, and for character it's 1. So that's for characters, right? So right, so I hope you remember all of that. By the way, the size of a pointer is 4. So because a pointer is storing an address, the address is generally can be fit into 4. When I say 4, I mean bytes. So we have 4 bytes here. So a pointer, this is a trick question actually. A pointer of a character and a pointer of an integer both will have actually size of 4 because they're both storing an address. The address itself has 4 bytes, so we need that value over there. So don't think that just because it's an pointer to a character we are going to have it as 1 byte. No, it's still going to be 4 bytes. So the first thing to remember there is, then we already automatically know that if the size of a pointer is 4, then over here we are going to get output 4 and over here we are going to get output 4, because these both are pointers. So we are definitely going to get an output 4 over here. So we are okay with that part. If you're doing MCQ and if you want to do like elimination, any of the options that don't have 4 and 4, leave them out. That's one thing you could do. But we won't go by elimination. We'll actually try to determine the answer, right? So size of array I equals to mod d and then size of array I. So size of array I over here is going to be nothing but the size of the entire array, and the size of the entire array here is a 4 plus 4 plus 4, which is 12, because there are 3 integers each of 4 there are 3 integers each of going to be of 4 value. So it's going to be 12. And over here we have 1, 2, 3. We have 3 characters, so this is 3. So the answer is going to be 12, 4, 3, 4, right? So the main thing we learned over here was the size of a pointer. The size of a pointer will be 4. So make sure you do that again. So the size of the pointer may vary on system, so this is an exception over here. Just go check it out. Generally speaking, if you are given a size of a pointer question, go with 4. That's the best option, unless the question gives you extra information, in which case read that information. That's going to help you, right? Alright, so that's mainly the covering of the pointers concepts over here. For those of you who've already done pointers before, who have some knowledge of pointers, you'll understand that this was a very basic covering. But I feel that if you do this much, at least some of the pointers question you'll be able to get. Obviously, if you get advanced pointers questions like 2D arrays and 2D character arrays interacting with 2D integer arrays, you're going to get some confusion, but that will only go away with practice. So the best way to do that is log on to the Edyst platform and actually click the programming MCQs, and you will get all of that stuff solved. Okay, so just go ahead and log on to the Edyst platform and you will get that part solved. The next concept that we're going to do is of order notation. So just before I get into order notation, I know many of you may not have even heard of what order notation is. So I'll explain what order notation is, and I'll explain some tricks on how you can get the order notation. Now, these tricks will be helpful for you, but don't think that these are, this is science, that it's going to happen just like that. It's going to be helpful for you. Okay. All right. So what exactly is order notation? First of all, it's not at all related to pointers. So just for those of you who just joined us, there are about six topics in programming MCQs that we have seen. Those 6 topics are these. Yes, in yesterday's part 1 section we covered this part, that is the decrement, increment, scoping, and associativity. And today's section we're covering pointers, order notation, searching, sorting. In this covering pointers we've just done, if you have any doubts and questions, please log on to Edyst platform and our mentors are there, will help you. 5, 6 are not related to 4. So the 5, 6 are not really related to 4. So those of you who just joined us, you missed the pointers part, you can rewind and check again. But 5, 6, which is order notation and searching, sorting, is a completely different topic, and we're going to cover that right now. So order notation itself, there are 3 things that you should know. There is a function called big O. This is called big theta. This is called big omega. So this is big O, big theta, and this is big omega. Okay. But what are these functions and what do they do? Well, purely mathematically, okay, so purely mathematically, what this does is, if an f of n is equal to big O of g of n, okay, this means that in the worst case scenario, okay, so what does this mean? It means that basically speaking, f of n is always less than equal to sum c into g of n. Okay, now this will seem very abstract to you and you'll be thinking, well, what exactly does this mean? All right, let me take an example and show you. Okay, so let's say we're just discussing big O of n. All right, and big O is the one that you're going to have most use of. Okay, so let's say some f of n is equal to order of n square. Okay, what this means is f of n at max, so this function of n is at max going to be less than equal to some c into some n square. All right, it's always going to be less than equal to sum of this value. Why is this important to us? I'll come to it in just a little bit. You'll understand what this means when we're going to discuss some algorithms, but this is what it means mathematically. That is, no matter what we do, whatever value of f of n we'll get, it will never be greater than some c of n square, and the c can be determined, but just generally speaking, it will not be, let's say, it will definitely be less than n cube, right? So at worst case it's going to be less than n square. Now, so at the worst case it's good, at maximum it's going to hit n square, not more than that. When we come to theta, so when we have theta of n, right, so this is theta of n, what we are telling is, if it's, let's say, let's say if order f of n is equal to theta of n square, let's say, and when I say n square, it can be any other function, but let's say it's theta of n square. What we're saying is f of n is bounded between some c2 of n, sorry, c2 into n. So this is, when I say this is into n, c2 into n and c1 into n. Okay, so basically speaking, sorry, n square, yeah, so basically speaking, f of n can at worst be equal to n square, but at best also it is going to be equal to n square only, some value of n square. So this f of n is going to be greater than equal to some n square and less than equal to some n square. Okay, so I mean, one really simple example could be that 3n square is always going to be less than equal to 5n square, but less than greater than equal to 2n square. What this means is, given that n is greater than 1, so let's say for n greater than 1, so this is for n greater than 1 over here. So what this means is basically 3n square is equal to theta of n square, right? Because for some value of n square, we are going to get that it is greater than some n square and less than some n square. So we know that 3n square is theta of n square. That's what this actually means. Again, this is very mathematical. Some of your MCQs might just come on this. It's all mathematical stuff, but just hold on for about 5 minutes and you'll understand how this actually plays a role when we are coming to analyzing algorithms. So the last one that we are going to do is called omega, and the omega means that at best it's going to be equal to n, which is nothing but, let's say if f of n is equal to omega of n square, right? It means that there exists an f of n, there exists a c such that it is greater than equal to n square, right? So c into n square, but the upper bound we don't know. The lower bound we know it's n square. That is, at best it's going to become n square, but at worst we don't know. It could even just go to infinity. So we don't know where it is. It's unbounded over there, but the lower bound is bounded, upper bound is not bounded. In this case, in the case of omega over here, the lower bound is the upper bound is bounded. So the upper bound here is bounded in case of big O, and in case of theta, both the lower end and the upper end are bounded. Okay, now what does this have to do with algorithms and C and programming and all of that? So what does this have to do with any of that? Okay, let's take some example and then we'll understand. All right, so let's say we have something like an array. All right, this array is not sorted. All right, so we have something like 3 7 2 1 0 5. Okay, and I give you a number key. I tell you key, and you're supposed to find this key value in this array for me. What's the best way to find it? Well, this array is not sorted, so the best thing to do is to go one by one and check each value where the array is, where the element is, where the key is. The problem with this is, what's going to happen is, let's say there are 1 2 3 4 5 6 there are 6 values here, right? When we have an array of size 12, we will have to do 12 iterations because the loop will run 12 times. Why? In the worst case, our key could be at the last element or could not be in the array at all. So even for us to determine whether the key is in the array or not, we still have to search the entire array. We have to go till the end. In the best case scenario, it could be the first element. We are happy with that. But we are looking at the worst case. In the worst case, what will happen? So for 12, it's this. For let's say 1000 elements, worst case scenario, what will happen? We will have to do 1000 checks. What about 10,000? We will again have to do, in the worst case scenario, 10,000 checks. As you can see, as the number n increases, the number of checks we have to do also increases. That is, since we are doing linear search is checking for each value from the start till the end. Since we are checking for a linear search from start till end, we have to check all of the elements, and if we have to check all of the elements, then as the number n increases, our number of searches or iterations are also going to increase, which means that our algorithm over here, which is nothing but one second. So now our algorithm over here, which is linear search. So let's say linear search is some function n. We can say that it is proportional to n. That is, as n increases, our time taken by this function also increases. That is, let's forget this part. Let's say the time taken for this algorithm to go ahead, that is to compute, increases by n. Now again, at every point we can get the first element also. The first element could be our key. We're not talking about the best case. We're talking about the worst case scenario. In the worst case scenario, what will happen? As n increases, our time to compute the search or to get the key also increases. This means that worst case scenario, our function is order n. That is, it's big O of n. That is, as n increases, in the worst case, we are always going to be bound by n. It's not order n square, right? It's order n, because the worst case scenario, we're always going to hit order n. Is it order 1? There is something called order 1 also. I'll come to that. But is it order 1? Order 1 means that at any given time, no matter how your n increases, no matter how your n increases, the time remains constant. That is order 1. In this case it's not, because as n increases, the time to search for the key also increases. So what is order 1? Let's look at an example. Let's say I give you a big array, right? So there's a big array over here, and your question is to find the sum of the first two elements. So we have the first two elements over here, let's say 0 and a of 1, let's say, and then 2, 3, 4, 5, right? Let's say our algorithm is to find out the sum is equal to a of 0 plus a of 1. Now, no matter how your array increases, let's say n right now is 10, the time taken will be the same. It will just take about one iteration to calculate this. When it's 100, you still require one time. If it's, let's say it's even 10 to the power 6, it will still take one, because we're just taking the first two elements. We don't care how big the rest of the array is. This algorithm is order 1. No matter how n is changing, our time remains constant. So we are proportional to 1, so it's order 1. Okay. Now, how does this help us? First of all, we discussed 2-3 things. We discussed over here O of n, theta of n, omega of n. What is happening? Well, generally speaking, for all our algorithms, we care mainly about O of n, big O of n. For your MCQs on Saturday and Sunday, they might ask you what is theta of n, there's omega of n, but generally they'll just give you some algorithms and tell you what is the order of it. And so that is what the big O talks about, that as the number increases, how does your time complexity increase? Time complexity is nothing but order notation. So what is the order of your algorithm? Let's look at some other examples to understand what, for example, could be order n square, right? So let's say we have an algorithm that takes an array, all right? So that does this, okay? So what's going to happen here is this array, let's say 0, 1, 2, 3, 4, and we have 1, 2, 3, 4, 5, okay? What this algorithm does is it takes one element and checks for the rest of the elements whether the element exists or not. Basically, it's checking for duplicates. So at this point it will open up this, say it's 1. Now it's going to check for the rest of the elements whether it's a duplicate or not. Okay, that's great. Then it's going to take 2, and again it's going to check for the rest of the elements. Then it's going to take 3, again it's going to check for the rest of the elements. If this is the algorithm, then how many checks are we doing? Well, at each stage we are going to do, the first stage we are going to do n minus 1, then we are going to do n minus 2, then we are going to do n minus 3, and we are going to do n minus 4 checks, and so on. Those of you who remember your series n minus 1 plus n minus 2 plus n minus 3 plus this, it comes up to a certain term, like it's going to be something like this. If we are going to have n n's, so we are going to have n square, right, minus it's going to be 1 plus 2 plus 3 plus so on, right? So, and what is the value of this? It's nothing but n square minus n into n plus 1 by 2. So this term, it becomes a polynomial in n square. So you're going to have some n square term, some n term, and on. What we do for order is we take the highest term. We have n square over here. We will take the highest term over here, and we will call it order n square, because it after a certain point the n square term starts dominating the other parts. Just leave that part if you didn't understand, but basically speaking, take the highest term. That is what the order of your algorithm is. It's going to be order n square. The order of this algorithm is order n square. Why? Because you did these many checks. The easier way to finding this out, instead of doing the maths for it, the easier way of finding this out is, let's say you have this array, right? So let's say I take this part out. You have this array over here. How would you do this check generally in your code? You would take a for loop, right? And you would go I equal to 0, I less than n, I plus plus, right? And then you take another for loop and you do j is equal to I plus 1, j less than n, j plus plus, right? Now what you have is, you have one loop here that is going n times, and you have another loop here that for each of this n goes approximately n times, not always n times, but approximately some n times. So you can almost take this as n square, because for each value of n you are going to do n approximately n iterations. So if you're going to do these many iterations, then this is going to be n square. That's a better way of analyzing that. For example, you have two for loops inside. That's a better way of analyzing the order of your approach. I would not say better, but it's an easier way of analyzing, because you will not want to do this maths. For some of the algorithms you might not also be able to do this maths. All right, so with that introduction into order notation, let's look at all of these algorithms: linear search, binary search, bubble sort, insertion sort, selection sort, and so on. Let's have a look at them one by one. And for this I'm just going to open up the Edyst platform and show you all of the visualizations that we have, so that for you it becomes better. Those of you who are already on Edyst platform, please make full use of this sorting part. Okay. All right, let's start with bubble sort, the simplest sort. All right, the one that everybody usually knows. Okay, so let me just get to that and open it up. All right, so this is bubble sort. I'm just going to open it up from here. Yeah, this is a revision bubble sort that we have. What this bubble sort does is it will at every step compare the two adjacent elements. So as you can see over here, it's comparing the two adjacent elements and it swaps them if the left element is greater than the right element. So 6 and 8 it won't swap, 8 and 7 it will swap. So let it swap. It swaps. Now it will compare 8 and 2. Is 8 greater than 2? Yes, it's going to swap 2 and 8. And then let's just wait for 8 and 4, and it's going to swap 8 and 4. Right, so that's what it's going to do. 4, 8, and this is just one pass of the array. Now it's going to do this again from the start. 8 is in the correct position, but it's going to do this again from the start. So you have over here, it's going to do this for 3, 5, then 1, 6, then 7. So it's going to do this again and again and again. So that's the what you could see, the algorithm for bubble sort. But what is the order of bubble sort? First of all, those of you who don't even remember bubble sort, please go to the Edyst platform, do the revision of bubble sort. The entire algorithm is mentioned here in detail. But if you look at the logic for bubble sort, okay, we have one for loop outside. We have sorry, so we have one for loop outside, we have one for loop inside, and then we do something with that. Just by looking at this, you can conclude that this will do n iterations. This is going to do some proportional to n iterations. So what we have here is an order n square approach. So bubble sort is an order n square. In fact, just coming back to our slides, all of these, so you could say bubble sort, insertion sort, and selection sort are all order n square. Merge sort is for sure order n log n, and I'll explain that in just a bit. And quick sort is worst case scenario order n square. On average it is order n log n. So again, these are values that you should know and remember. So if you remember these values, they will be really, really useful for you in the programming MCQs part. Okay. All right. So just coming back to this, for bubble sort we have this. Let's just open up insertion sort and understand how insertion sort is also happening. Alright, so just going back to the Edyst platform, opening up the revision, what we have here. So where is that? Yeah, so I'm just opening up the Edyst platform and going to insertion sort, revision of insertion sort. Yeah, so we got it here. So in insertion sort, the way it works is we keep two arrays. We keep a sorted and an unsorted array. So what happens here is there's one part, the sorted array, and then the unsorted array. We keep inserting from the unsorted array into the sorted array, such that the new array should also be sorted. So if you look at this visualization, it might be too fast. I'll just explain it quickly on the slide. The way it works is, this is for insertion sort. All right. Yeah. So for insertion sort, what we have is, let's say you have 4, 3, 1, 0, 2, 5, right? You will take the first part of the array to be sorted and the remaining part to be unsorted, because this 4 is already sorted, it's just one element, so it's sorted. Then you will take the first element of the unsorted array and try to insert it into the sorted part. So what's going to happen here, when you insert it, it becomes 3, 4. This part is sorted, the remaining part 1, 0, 2, 5 is unsorted. When you take 1, you again insert it, it becomes 1, 3, 4. This part is sorted, then 0, 2, 5 is unsorted. You take 0, inserted, it becomes 0, 1, 3, 4, sorted, 2, 5, unsorted. You take 2 and you insert it, you'll get 0, 1, 2, 3, 4, sorted, and 5 is unsorted. When you finally insert 5, it will become 0, 1, 2, 3, 4, 5. Now this is the insertion sort. If you go and look at, you can just go and read the entire revision to get a better understanding how insertion sort works. But what you can see again from this clearly is, we are going through each element. That is, we have to go through each element anyways. So that's a for loop in itself, right? So that's a for loop that's going to go for n times. Then after that, for each of the element that we're inserting, we might have to traverse the entire thing. So whenever we go 1, we have to probably go through the entire thing and insert it here. At every point, we could have to insert it at the starting again and again. In which case, this becomes proportional to n. As n increases, the number of times, the number of places we have to skip also increases. So over here also, we are going to do some n types of what you could say, you're going to do some n types of iterations. So if there's an outer loop with n, inner loop with n, this also becomes order n square. Again, this is not the mathematical way to do it, but this is a simple trick to figure out how to find the order of a sorting algorithm. The last one, let's look at selection sort. The way selection sort works is, again, let's take the same example that we had last time, 431025. So the way selection sort works is, it's in the name. Selection sort means you select the minimum of the array and always try to bring it to the start. It also has an sorted and an unsorted part, right? So what you do is, this is the sorted part. You first select the minimum from the entire array. So the minimum from the unsorted part is 0. You compare 0 with 4. Is 0 less than 4? Yes. So you swap it. So you bring 0 over here, 3, 1, 4, 2, 5. Then you mark this part as sorted. So this is sorted. Great. Then next what you're going to do is, you're going to take, so this is sorted, we don't touch this. We are going to take 3 and compare it with the minimum from 1425. Alright, so you have 0, 3, what is the minimum from 1425? It's 1. So we take 1, compare with 3, 1 is less than 3. So we bring it that here, we swap them. So now we have 0 and 1 as sorted and 3, 4, 2, 5 as unsorted. Again, take the minimum element out, you will get 0, 1, 2, 3, so, 3, 4, 1 second, 0, 1, 2, 3, 4, 5. Yes, that's what will happen, because 2 and 3, 1 second, that was wrong. Let me just, anyway, so this part is wrong. Let me just just cross that out. So what you have over here is this part. When you brought 2 here, 3 goes there, so it becomes 0, 1, 2, 4, 3, 5. Yes, that's what it will become. Then this part, again we're going to take 3 and swap with 4, 0, 1, 2, 3, 4, 5, and then finally 4 and 5 you're going to compare. So again, at this part you're going to use 2 for loops. One for loop is to select the element, so you're going through all of the element, and finding the minimum itself will get you another for loop of n times. So this also is order n square, right? For a detailed analysis of this, again check the reading material. We have a much more detailed analysis in the reading material on how this can become order n square. But if you didn't understand, or if you are having trouble remembering, just go and remember this slide, that over here we have bubble, insertion, selection sort as order n square, merge sort is order n log n, quick sort is order n square, worst case, average case, order n log n. Okay. Now when it comes to linear and binary search, if you remember, linear search we just covered when we were doing big O. So at that time, linear search is order n, binary search is order log n. Alright, so but how is it order log n? Pretty simple. For those of you who don't remember your binary search, let me just refresh the binary search part for you, and we will again go to the Edyst platform for a very simple understanding of how binary search works. Alright, so just opening that up, 1 second. Yes, so we have revision of binary search. There we go. Yeah, so revision of binary search. The way binary search works is, do we have the all right, yeah. So what binary search will do is, let's say you have a certain key that you want to find, right? And this is the array that you have. What it's going to do is, it's going to check the middle element. The first thing that binary search assumes is that your entire array is sorted. So this is again a trick question for everybody. If your array is not sorted, binary search cannot work. So to get binary search to work, you have to have the array sorted. So let's say you have this sorted array. Let's say you're searching for a number. Let's say you're searching for 92, right? So that's 92 over here. Now, but how do we find it? Well, you have this array over here. What you're going to do is check a of mid. A of mid is nothing but at this point 64. So because 7 divided by 2 will be 3, you check the 64. Is 92 greater than 64? Yes. So you can discard this entire left side of the array. The entire left side is discarded. You have to only look at the right side. when you look at the right side, you can again check the mid of this part. So 7 minus 4 is 3. 3 divided by 2 would be 1 second. 3 divided by 2 would be 1. So this is the mid part. 84 is the mid. So is 92 greater than 84? Yes, it is. So it's going to be on this side. So what we are actually effectively doing is, because the array is sorted, at every point we are dividing the array into half and figuring out where to look at. So again, let me just explain this by an illustration, and this is actually the last thing that we're doing today. So let's say this is the array, right? What we're going to do is, there are 0, 1, 2, 3, 4, 5 elements, right? If we have a key to search, we first, and this is a sorted, by the way, please remember that this is sorted. We'll first check this part. If the given key is equal to this number, great, we are very, very happy. If it is not equal to this number, then we check, is it greater than the number? Then we know for sure that it's going to be on the right side. If it is not greater, if it is lesser than this number, then it's going to be on the left side. Okay. So at every point we are dividing the array by 2. So for example, when we did, if the array size is n, right, we check the middle value. If it's equal to the middle value, great. If it's not, then the next part of the array that we're going to check is the other half. So we have n by 2 elements to check for. Then we're going to check n by 4 elements. Then we're going to check n by 8 elements, and so on. So the way this keeps reducing, right, how many such values will be there till we reach 1? In worst case, the number of values here is going to be log of n base 2. Okay, and I won't go into the derivation of it. Those of you who've done quants aptitude, you'll pretty much be able to solve how this is the case. But at max, we are going to do n log n base 2 number of repetitions. We are not going to do more than that. Okay, so if this is the case, our binary search becomes order log n. All right. For merge and quicksort, we'll have to spend a lot of time understanding, so I won't get into that. Just remember that merge sort is order n log n, quicksort is order n square, worst case, order n log n average case. So generally it's order n log n average case. So over here you have order log n for binary search. So just to recap whatever we've done today, these are certain questions that can be asked in your programming MCQs, but the major questions that are going to be asked for you is the questions that we've already covered in part 1. So that is decrement, increment operator, comma operator, scoping and associativity. So please go and do revise your part 1 webinar that was there last time. Yes, so yesterday we did that. Please do revise the part 1 webinar. And today's webinar we covered C pointers, order notations, and searching sorting. Please go and check out the Edyst platform for more information about these topics. Very specifically for order notation and searching sorting, we have a lot of tutorials. So do go ahead and check that out also on the Edyst platform. If those of you who are preparing for placements, not only for NQT but also for the upcoming other drives that are happening, that's exactly why we made this complete coding pack. So that's the complete coding pack that I've been referring to so far. This is the TCS previous year's questions, where we have all of the programming MCQs, and if you want the searching and sorting part that we discussed, that's in the warm-up part. So if you just go to, let's say, warm-up, so that's warm-up 2, and you go to searching, you will get all of the stuff that we talked about. Searching, sorting, you'll get all of the stuff that we talked about. Right. So it's not only for NQT. These topics are going to be repeated again and again. They're going to come again for AMCAT, again for Mindtree. So prepare once so that you can give it every time. Do sign up for the complete coding pack so that I'm online, the other mentors are online. They're more than happy to help you in clearing all of your doubts. So that's it for this session right now. We are going to go into a Q&A mode. So all of the question answers that everybody has. So all of the question anybody has, I'll be answering them. I'll just ask my team right now whether anybody has any questions. Happy to help. And the major thing that I want everybody to do is please subscribe to this channel, because if you subscribe, we come to know that you're interested, and the more you subscribe, the more people will come to know. So do share this video with your friends, especially everybody. I know I was an engineering student. Everybody prepares at the last minute. So help everybody with the last minute preparation, with the last minute revision, and do share this video with them, and subscribe to this channel. It will give you all of the notifications, not only for the NQT series that we're doing, but as I said, this is the placement time. We are continuously doing more and more webinars every day. to help you clear the next rounds of all the companies. So yeah, I'll wait for the questions if anybody has any questions.
So yeah, with just about one odd day left, people are asking uh, quick tips and tricks. They're saying that while this what you have explained has really helped them a lot, within the MCQ, are there possibilities that they might get other than C?
Okay, so very good question here. There's a few days left, so actually just one day left, and we have to do all the preparation we can. In the MCQ, is it possible that we get anything other than C? So my understanding of it is that the programming MCQs are generally based on your first year syllabus. So first year, second year, basically your subject knowledge syllabus. So that's what it's based on. Could you be asked outside that? Well, they could ask you anything. That's TCS's prerogative. They could ask you generally, but as per last year's pattern, we have not seen any other MCQs apart from C. We have seen mostly C and algorithm based. So look at order notation. If you look at bubble sort, selection sort, these don't depend on the language. Bubble sort will be order n square in C also, in Java also, in Python also. It's not going to change its order. So when it comes to order notation, searching, sorting, all of this is constant across all languages, but pointers is very, very specific to C and C++. So generally we've seen them ask questions like pointers and all that are very specific to C, C++.
So while we learnt a lot about programming MCQs and coding itself, any inputs for the English and quantitative aptitude, which is 15 plus 15 marks?
Okay, so any inputs for the English and quants? So now is the right time to actually go and revise all of your English and quant stuff. Very specifically, there are a bunch of free websites that will help you. There's indiabix.com, there's I think campusplacements.com or something. So there are about a bunch of websites. You can just Google them and find, and there are a lot of these available. The best part about aptitude is they're freely available. The explanation is also freely available. It's not like a coding thing where you have to do a run, submit. If your code is not working, you have to check with somebody has to check. Here the answer is either correct or wrong, right, in terms of inaptitude. So I think I would say just go and revise on. There are a lot of free material. Probably your college has provided you material. There's a lot of stuff over there. Go revise that. Generally my understanding is if your maths in terms of AP, GP, those kind of things, profit loss, permutations, combinations, and probability, if your maths is strong in that, and for English, just general reading comprehension, subject noun, subject verb agreement, nouns, all of that is there, generally you should be able to crack it. So now is the good time to spend a good 4 to 5 hours in just revising all of these topics. They're basic GK, not GK, but these are like if you've done engineering and you've done +1, +2, you should be able to crack. So spend good 4 or 5 hours now, and it will be a good revision for you.
So some of the people very humbly and are asking that especially sorting and order notations were slightly more complex for them
Right,
to
right.
digest. What advice do you have for them?
So for those of you who found order notation and searching sorting complex, the reason you might have found it complex is this is the first time you're hearing of the concept. It's actually one of the easier concepts, and trust me, once you get used to it, you'll understand that it's much easier than what it seems. What I'd suggest is for order notation and searching sorting, first go for searching sorting. Like forget about order notation for now. Go for searching sorting first, and understand all of the sorts. Understand bubble sort, selection sort, insertion sort, merge sort, quick sort. These 5 sorts, understand it to the core. Once you've understood that, then also come to binary search and linear search. Once you've understood these 7 things, then try to understand how each one of them is order n square, order n log n, order log n. You will understand it. So first go for searching sorting, come to order notation in the end, do some sample questions on order notations like 7 or 10 questions. You'll be able to get a hang of it. It's a new concept, that's why you're finding it difficult. It's not really that difficult. You analyze 2 3 questions, you'll get it.
So while this is all about MCQs, we have very genuine questions coming saying that can you just show us or point us what we should do on the programming side?
So on the coding side, what are some of the things that you should generally be preparing for? What I'd say is there are 2 points here. The first thing that I'd suggest is so I'll just open that up. Just give me a minute, 1 second. Yeah. So we had discussed this. So generally, the kind of questions that we have noticed coming for 1 second. Yeah. Okay, give me 2 minutes. I'll just get up the. Yeah. So these are the kind of topics that we have generally seen being asked in the programming side. So that's maths, conditionals, loops, pattern, arrays, and also strings. We have one webinar dedicated to each of these topics. So I'd suggest you go and check the NQT playlist of Edyst on the Edyst YouTube channel. You'll get one webinar specifically on all of that, on all of these topics. I give tips and tricks on how you can solve each of these topics. For those of you who are not really confident about even if they can get these parts, at least maths, conditionals, and loops, we also have free module available for you in the warm-up section. So if you go to the warm-up section of the Edyst platform, you sign up for the complete coding pack, and you go to the warm-up section, you have functionals, conditions, loops, and also a little bit of maths freely available. At least attempt these, so you'll get a feel of those, and you can go ahead and actually sign up, sorry, go ahead and view some of our previous webinars. We have a dedicated webinar on all of these, so go and check the webinars. They have one question being solved in that webinar, so please just check that and you'll get it. So if you're just starting the coding and the programming section, first stop is to go and check the webinars on these topics and try to implement them yourselves on your compiler.
Uh, a lot of questions are all about what can we expect on the Edyst webinar tomorrow.
So what can you expect on the Edyst webinar tomorrow? So we have generally covered all of the topics. For those of you who want to know more about the webinar, the best thing you can do is sign up on the Edyst platform for the complete coding pack, for the free pack. And once you get that free pack, you're on our mailing list. We will send you an email about what you can expect tomorrow. Because we have covered all of the topics, we're thinking of what's the best thing to do for you tomorrow. If you have any suggestions, let us know. We'll also do that. But generally, it will be like a big revision of what all we have done so far. So you'll get all of the links and material on if you have to do the last minute preparation for NQT, what would happen. So to get notified about our upcoming webinar, subscribe and subscribe to this YouTube channel, and also sign up for the free complete coding course. That is the free module. At least if you sign up for that, you will get all of the emails regarding any future activities that we are doing.
I think that's exactly the follow-up question to what you just said. Can you tell us what do you mean by sign up?
So what do I mean by sign up over here? What I mean is I'll actually just pick that up and show you. So if you go to the edyst.com website, 1 second, just bringing that up over here. Yeah. So if you go to the Edyst website, what you see is the complete coding and interview preparation pack. You just need to go down. This is the complete coding interview preparation pack. You can click start now. And once you click start now, what you will get is, 1 second, this. Yeah, so you're going to get this. Click apply now. The moment you click apply now, you will get a window asking you to send your your name, email ID, phone number, etc. So that's what it's going to ask. And once you click that, you are signed up for the free session. So you'll get this login via Google and Facebook. Once you actually log in, I have already logged in, so my details will already be there. So I'll go directly to the place. So the moment I click login and I enter my details, I'm going to get access to this particular cohort over here. So let me just bring. So this is what you will see, and this part will be free for you. So this first box will be free for you. Basically, once you've signed up, entered your details and stuff, we have your email ID and we'll keep sending you all of the emails.
Are there going to be any linked list MCQs?
So are there going to be any MCQs based on linked lists? Generally speaking, I have not seen any questions asked on data structures as such in the previous year's MCQs. None of the questions on the programming side, that is the coding side, also did not seem to be on MCQs. Having said that, if you're already an advanced student, please go revise a linked list stacks and queues. If you're somebody who's just started thinking about the coding around today, don't even think about linked lists right now. You have better things to do. You have to do pointers, you have to do increment, decrement operators and all of that. So in your MCQs, just focus on the topics I covered today and yesterday. But if you've already done all of this, then there's no harm in doing a little bit more and understanding linked list and stacks and queues and all of that.
Yeah. If you can wind up once again for everybody who's still there.
So
what are we going to do tomorrow?
So what are we going to do tomorrow? So this is the wrap of today's webinar. Just again requesting everybody to subscribe. What we're going to do tomorrow is we're going to do a specific revision pack. So what we'll do is to all of those people who are already on the platform, we'll send out an email specifically saying about how you can revise, and we'll do a quick webinar explaining on what's the best way to revise. Again, Saturday, Sunday is going to be your NQT. In the last minute, there's only so much you can learn. So we'll do a quick revision of all of these topics, or we will give you links on where you can do the quick revision of these topics. So stay tuned for that, and if you have other suggestions, please let us know. We are happy to do that also. Right, so thanks everybody for being live on the webinar. It's great to have you on this journey. All of you were there for Code Vita's webinars. Now you're there for the NQT webinars, and from next week we're going to start for the next company as well. So those of you who get placed in TCS, great. Those of you who don't, stay with us for the next company, and we'll do webinars for that, and we'll keep doing until all of you are hopefully placed. Right, so thanks again for joining. Subscribe, and if you like this video, please share with your friends. We would like to help more and more students get placed. Thank you so much for joining, and if you have any doubts and questions even after this, you can just log on to the Edyst platform and chat with me, or you can chat with any other Edyst mentor, and we are more than happy to help you. So thanks everyone, and see you next time.